basically the same process here. Finding a missing variable, whether it has a binomial like number 5 does, or whether it's just a straight proportion like 1 and 2. You can use cross multiplication. I picked this one because I just want to make sure that you are putting parentheses around these when they're grouped. So when you do cross multiply, you do need to distribute that 10 through. And then you can simplify from there. This one is actually going to be a fraction. So we get add your 30 over. Your answer key is in decimal form, which is fine. All right. So just straight cross multiplication there. The next section is actually the same. What you want to do is wherever there's a question mark, you want to put your variable there, x. And then you're just going to set up a proportion. I typically put my smaller figure on top and my larger figure on bottom. Pick sides that correspond. So I have 7 and 42. Those are corresponding sides. So I can say 7 over 42. Can you reduce that? Yes. What does that reduce to? 1/6. So I would use that and then go to the side where you have the question mark. You can do cross multiplication here, or you can just say 6 times what equals 18, but you're going to get x equals 3. But it's the same concept once you set those up. 1 times 18 equals 6 times x. So once you set it up, it is exactly the same as the first set of questions that you had. You can just use cross multiplication to do it. A couple things. It says, state if these are similar. If so, state how you know, and complete the similarity statement. The only time you're going to complete that statement is if you're telling me they are similar. If your answer is not similar, that you're telling me they are not similar, then you're done. All right, you cannot give me a reason because there is no reason for the similarity. And you're not going to complete a similarity statement because they're not similar, okay? But if they are similar, you're going to tell me a reason, angle, angle, side, 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 or side, angle, side, one of those three. And then you're going to complete the statement with the second triangle. So for this one, we have 2 triangles, even though they are inside of each other. We have the outside triangle here, which is the JKL triangle. So we have this one. And it is compared to the inside triangle, SRJ. Do we know anything about the angles of these triangles? We don't?
We know that those two are the same angle.
Right, they share an angle. So anytime they share an angle, then you automatically know that angle is congruent, right? Because they share an angle. We don't have all 3 sides, so that is out. We don't have any other angles, so that is out. So what we can do is we can compare side, angle, side. If this is going to be similar, it's going to be similar by side, angle, side. We have the angle and we have the sides on either side of that angle. So we can compare them. All right. If this is 54, we need to compare it to this side, right? Which means we need to compare whatever this is to the 56, hopefully. All right. So how do we know what this side is right here?
8 minus 6.
Yeah, 56 minus 8, which gives us what? 48. So 54 over 63 must equal 48 over 56 in order for this to be side, angle, side. All right. So do those reduce then? 54 and 63, what goes into both of those?
7.
6 over 7. What goes into 48 and 56? 8 gives you, they are the same ratio. So yes, these are similar. And so part of your answer here is going to tell me they're similar by side, angle, side. That's part of your answer. Are they similar? Yes, by side angle side. Since they are similar, then you want to complete the similarity statement. J should correspond to which angle? That's easy. J, it corresponds to itself, right? K in the larger one, K in the larger one should correspond to R, and L should correspond to S. So your answer has to be in that order, J, R, S. You need the triangle symbol, and you need it to be in the order J, R, S. All right. Look at the next one. Look at 15. Can I say anything about the angles whatsoever? No, they did not give me any information. So I must only be testing one of my similarities. What's the only one I can test here? Side, side, side. All right, so all three of the sides have to be in the same ratio. So I'm going to go the smallest side. What's the smallest side on this triangle, the smaller triangle? Yeah, so it's 44 actually, right? So what's the smallest side up here? Which is 117, right? The CB. That should equal the next smallest side. Next smallest side here is, on this one is what? 45 compared to 118. And that should be equal to my largest side, 60, compared to 156. All right? What's the problem here? This one here, 2 doesn't go into it, 3 doesn't go into it. Like, can I reduce that at all? Probably not. So if I can't reduce it, we automatically know it's not going to equal those two. Even if those two can reduce, if the first one can't, right? So even if I were to reduce the other ones, these are not going to equal the same. So I'm actually, my answer here is just going to be not similar. That is my entire answer, not similar. I do not complete the similarity statement. I do not put side, 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 because side, side, side would indicate that it actually meets the requirements of side, side, side. All right, so my whole answer for this one is just not similar. Those two triangles are not similar. All right, so for this one, I would probably use color if I were you, and just to make sure that you are comparing the right things. If not, you may get a little confused as to which one to put over. First of all, they tell you that these are similar. So it's different than the one you just did where they're asking the question. Here they are actually stating these are similar. All right, so that means U to V should go from U to B. So U to V is going to be compared to U to B. And then V to W should correspond B to C. And then U to W should correspond U to C. And so that's how you want to set up those ratios there. All right. So my variable that I'm looking for is right here. It's always a good idea where the question mark is to write the variable. So 54 over my variable should equal 78 over the 91. If you can simplify, you can. If not, at this point, you can legitimately just do cross multiplication. So 54 times 91 should equal 78 times x. And you actually get that x equals 63 here when you do this one out. All right. But if you do not pay attention to the order of that similarity statement, you may switch it up and put the wrong one over the wrong one, and then you'll have the wrong answer at the end. So you have to set this up correctly to get the right answer. You have to set it up correctly to get the right answer. All right. This next one, the only difference here is that it has a variable in the answer itself. Once again, you want to pay attention to the order. ST should correspond to PQ. So I'm going to say S to T should correspond P to Q. And then RP, which is the other one that I'm looking for, R to P should correspond U to S. U to S. All right. And so I would set this up 6 over 24, and you can reduce that, equals 2x plus 3 over 52. So if you want to reduce the 6 over 24 first, you can. 1 over 4 equals 2x plus 3 over 52. Don't forget, though, that when you do this, you need to distribute. So I have 4 times 2x plus 3 equals 1 times 52. All right. And then in this case, you're solving for x. So in this case, you're actually solving for x, not the length of the side. Any questions on those? All right, so don't forget the geometric mean equals the square root of the 2. And so you have several here. Depends on what you're looking for. Here they're looking for the entire hypotenuse of that large triangle. So here, the side over here, the leg, is the geometric mean between the closest piece of it and the entire hypotenuse. So that means 60 is the geometric mean between the 36 and the x. Since my x is on the inside, I need to square both sides. 60 squared is going to be 3,600. Equals, when I square the square root, it just goes away. And so I'm going to get that x equals 100 here. X equals 100. I picked out the next one because it is a little bit different. It is a little bit different. So let's look at number 29 together. They want me to solve for x, all right? 60 here is the geometric mean. It's actually the same exact numbers between this and the entire hypotenuse. So I'm going to assign a different variable here because I want that. I don't want the entire hypotenuse. I actually want the piece of it, the piece of it. 60 is the geometric mean between 36 and the entire hypotenuse. All right, we just figured out, by the way, this was the same exact problem, that the entire hypotenuse is 100. That is not what it's asking for in my final answer here. What is it asking for? It's asking for that little piece of it, this little piece of it right here. So how do I find that? If my entire hypotenuse is the 100, what do I need to do? Just subtract. And so here, my answer is actually going to be 64. So pay attention to what they're asking for and what your geometric mean gives you in that situation, okay? If they had been giving you this guy right here, he is the geometric mean between those two pieces, and you would have just solved for it, right? But because what they gave you for is not the geometric mean, then you need to make sure you know which it is. All right, let's quickly go over the geometric means. All right, so when we have something like this, and we have my altitude right here, we have a couple things that are created. The altitude is going to be the geometric mean between the two pieces of the hypotenuse. So here the altitude is going to be the geometric mean between the two pieces of the hypotenuse. All right? One side of your leg, though, is going to be the geometric mean between the piece of the leg that's closest to it and the entire hypotenuse. Okay? So that means this one would be the geometric mean between the piece of that is closest to it and the entire hypotenuse. Those are the three geometric means you need to know in your right triangles. Okay? Those are the three geometric means you need to know. The altitude is between the two pieces of the hypotenuse. The legs are the one closest and the entire hypotenuse. The one closest and the entire hypotenuse.